Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to our presentation. We are from Team 14, and there are Calvin Wijaya, Noval Fatan Shafa, Rizal Mubarak, and I at Arvidaningrum Diapriana. To this presentation, we are going to discuss about the analysis of open green space availability in Surabaya City using OBIA classification. So, today's discussion, we are going to talk about the background why we choose the title and study area, instrument and materials, methodology, results and discussion, and last but not least, conclusion. Let's move on to the background. According to Article 1, the Law Number 26 of 2007 regarding spatial layout, open green space is a ribbon and/or a grouping area with a characteristic of open utilization, placed to grow plants either naturally or artificially where the proportion of urban open green space is at least 30% of city area. Furthermore, Article 30 explains that the distribution of open space is adjusted to the distribution of the population and the surface hierarchy by taking into account the structural plans and spatial patterns. If the above ideal conditions can be realized, then we can feel many benefits, namely security, comfort, welfare, and beauty of urban areas. In the context of air pollution, open green space can balance the supply of oxygen needs with the carbon dioxide absorption. Carbon dioxide levels in the air in normal amounts are very useful for protecting life on Earth. However, an excessive amount is very dangerous. The carbon dioxide content in the air is currently considered to be the cause of the greenhouse effect. Examining the function of open green space in urban areas in particular shows that open green space can not only function as a self-purification for the city air, but also as a supplier of oxygen for city living creatures. Besides, open green space also plays a role in maintaining the balance of the hydrologic cycle for the city concerned. And the next one, the development of remote sensing technology has benefits in various fields of study, one of which is for the study of urban phenomena. One of the studies related to urban phenomena is open green space. For urban areas that have complex objects, visual interpretation methods will be difficult to apply, take a long time, and are subjective. Therefore, to make the identification of open green space easier, digital interpretation is used with the object-based classification method. Object-based classification, known as object-based image analysis, or also can be called OBIA. OBIA can identify an object based on both spectral and spatial aspects, so it is considered capable of overcoming the shortcomings of image classification that only relies on spectral aspects. OBIA consists of two parts, namely image segmentation and classification based on object features from spectral and spatial aspects. The next one, there is study area. The location of this research is limited to the Surabaya municipality. The reason of choosing Surabaya municipality as study area because it is one of the largest cities in Indonesia. Important for a city to have minimum open green space to ensure the city doesn't bring any harm to the environment and also makes the city sustainable for development. Surabaya is also a port city where many economic activities occurs there. With economic growth, a city or country tends to grow, increasing in size and changing its structure. Economic and population growth will also increase the need for land for the development of economic centers and settlement, which in turn will encourage changes in land use, especially the decrease in open green space. Because the importance of the city, this research will analyze the availability of open green space and make an assessment whether or not it's already past the minimum threshold of city having open green space. To support the data processing in this research, we also need some instrument and materials. The instruments used for this research are as follows. Google Earth Engine, used for searching the data, pre-processing the data, analyze and processing the data, and export the result. The second one, Google Earth and Google Street View to see the location for training and validation dataset. Materials. Data used in this research are as follows. The first, Sentinel to MSI Level 2A, The reason choosing this imagery because its resolution higher than Landsat 8 even after pen sharpening. Sentinel 2 has spatial resolution in 10 meters, while Landsat 8 has spatial resolution in 15 meters. We choose level 2A because it is already in reflectance values, not in digital number anymore. Surabaya City administration boundaries. We also need the administration boundaries for clipping the imagery, so we don't need to process all the selected region of interest that has been chosen by the Google Earth engine. And the next slide will be presented by my friend Calvin Wijaya. The time is yours.
Thank you, Anna. For the next section, we will present to you the methodology we use in this research and step-by-step to processing the data. As we can see on the screen is a flow chart of what we do to process the data. In general, there are three main steps: pre-processing the data, classification, and accuracy assessment. Pre-processing data is a step to make sure the data is ready to classify. The next step is classification. We use two approaches in here. There is pixel-based and object-oriented classification. Both of it need training and validation, so we make sampling to choose training and validation dataset. Classification is done using random forest algorithm. Last step is to do accuracy assessment to make sure the classified result is true. The first step is data preprocessing. Data preprocessing aims to make the data ready for classification. It consists of three steps. There are filtering, to choose Sentinel to imagery with right period of time. In this result, we're using 2021 and in the right location, that is Surabaya. After that, we do cloud masking to make image is clear and free from cloud, so it's easier to determine training and validation dataset. Last is to calculate NDVI and BSI band ratio to improve the classification accuracy. From the screen, we can see before and after the pre-processing image. In this result, we need to classify land cover of Surabaya. We assume 6 classes to represent Surabaya. There is urban, mangrove, pond, rice field, and open green space. Because of that, each classes need its own training and validation dataset listed on the table on the screen. In total, we make 45 training data and 290 validation datasets. Distribution of validation and training dataset are shown in the screen. The right up above is training dataset and below it is validation dataset. After we choose training and validation dataset, we can directly classify the image using pixel-based approaches. Meanwhile, for object-oriented approach, we need two additional bands. There is segmentation and textural indice analysis. In this result, segmentation is done using SNIC or simple non-iterative clustering algorithm, while textural indices using GLCM or gray level co-occurrence matrix. SNIC segmentation is an improved version from SLIC, but both using the same concept to cluster the data. It using k-mean clustering. As you can see on the screen, the left one is pixel. The aim for segmentation, we want to make the superpixel the right one. So it clustering the pixel with the same value. As we can see on the left image is concept of k-means algorithm. K-means concept use k number of cluster. As example, in this image, we want to classify data into 3 clusters, red, green, and blue. We choose a random pixel to make it as first centroid. Then each pixel will calculate its distance to centroid and assign to nearest cluster. After that, we can calculate average of data and get centroid to, and then repeat the process. SLIC using this concept to cluster pixel, but instead to calculate all pixels across the image, SLIC make a boundary box, so it only calculates pixels inside the box as shown in the right image. In this result, we use SNIC, simple non-iterative clustering, an improved version of SLIC. It's more efficient because it's not iterative like SLIC. It's possible because SNIC make a priority queue which pixel can be assigned to a cluster. As you can see in the picture is image before segmentation and after the segmentation. After segmentation is done, next is to calculate GLCM textural indice analysis. The concept is to calculate 2 neighbor pixels using distance and orientation. The input of this process is a gray image, so first we convert the RGB image into the gray image. The output of GLCM is 7 features. Then we use PCA or principal component analysis to simplify the data into one representative band, which generally contains vast majority of texture information. The result of GLCM texture shown in the right side of the image. After segmentation and textural analysis is done, we combine those two bands as input for classification. We use random forest algorithm in classification. For pixel-based classification, it only uses band 2, band 3 until band 11, like original band from Sentinel 2. But for object-oriented, we add two more bands as parameters for classification. They are cluster from SNIC segmentation and PC1 from GLCM. These two parameters makes big difference between pixel-based and object-oriented. And last step is to calculate accuracy assessment. There are 5 parameters we use to calculate accuracy. There are confusion matrix, a matrix that tells how accurate classification results compare with validation data. Second one is producer accuracy that shows omission error. And then the third is user accuracy that shows commission error. Overall accuracy that shows total validation data is correct. And the last one is kappa. We refer to LAPAN regulation to find minimum threshold for accuracy assessment that state minimum overall accuracy for classification is 75%. For the next section, we will discuss about result and discussion will presented by my friend Rizal. The time is yours.
Okay, thank you, Calvin. In this session is result and discussion. There are three main results. The first is object-based versus object-oriented classification accuracy. The second is green open space area calculation based on OBIA classification. And three, green open space analysis. Habis itu gimana kalau udah ini? Okay, next is pixel-based versus object-oriented classification. From the classification result using pixel-based and object-oriented, as shown above, there are some differences between them. Although the distribution of the class result is similar, like the point is located in S of West Surabaya City in both classification result. Some difference occur in many classes distributed in all image. But from the visual judgment in zoom of level picture above, both of these does represent the land cover of Surabaya City with pixel-based object-oriented. In this part, there are three images. First is original image, second pixel classification, and the third is object-oriented classification. But if we take a closer look and compare between original image and both classification result, like the picture above, we can see big differences between pixel and object. For the same are shown in original image, there are settlements in the area. It shows a grid in object-oriented where it considers as houses block or a settlement. We can compare with pixel where it is classified based on pixel digital number value, so the result like above has a hole or gap between houses. OBIA considers the classification feature as an object not classified based on pixel. In here we can see object oriented is superior than pixel classification. Okay, next there are pixel-based versus object-oriented classification. As you can see, there are two tables. The first is pixel approach confusion matrix, and the second is object-oriented confusion matrix. Total validation sample is 219 data divided into 6 classes to represent land cover in Surabaya City. From the picture beside shown confusion matrix for both classification methods, we can see from diagonal of each matrix shown that object-oriented result is more accurate than pixel-based. It shows the reference data that correctly write with classified data in object-oriented is higher than pixel-based. Based on each confusion matrix, we can calculate user accuracy and producer accuracy for each class and for each classification method, as shown picture beside. The table shown that object-oriented has higher accuracy than pixel-based for all classes except in Tambak class. But all 5 other has higher accuracy in OBIA than pixel approach. Comparison of overall accuracy from classification result between both method and kappa value shown in the table behind. We can see that OBIA has 8 higher accuracy than pixel based from the kappa value, also shown that OBIA is more accurate than pixel based. Okay, the next discussion will presented by my friend Nopal.
Thank you, Rizal, for your time and place. Now we are about discuss the green open space area calculation. By using Google Earth Engine, we can calculate the area of each class. That the result was shown in this table. From this table, the total area of Surabaya City is about 336,517 kilometer cubic, divided into 6 classes. The first class and the largest is the urban area that covering about 134,130 kilometers cubic, while the smallest is the mangrove that only 10,043 and 843 kilometer cubic. It is logical to remember that the Surabaya is a big city, a port city where economic activities happen as a routine, so urban area is the largest area. And this is the graphic about the total of land cover average of Surabaya City by the result of this classification. The next discussion is about green open space area analysis. Based from area calculation before, we can analyze how much Surabaya City needs green space area. And this is the diagram of percentage the land cover of the Surabaya City. Based on the Article 1, the law number 26 of 2007 regarding special out, the proportion of urban open green space is at least 30% of the city area. It means the area is about 100,955 kilometer cubic is the green open space. Meanwhile, after the classification, the green open space is only 63 and 720 kilometer cubic. It means only 19% area in Surabaya City that are green open space. Therefore, the Surabaya City needs about 11% to fulfill this 30% of green space area. Okay, ladies and gentlemen, this is the final result of our project. This is the classification map about land cover in the Surabaya City. This map include the urban mangrove, tambak, sawah, tegalan, and RTH that are viewed in this map. Now we come to the end of the presentation. From this research, there are several conclusions that we made. The first one is object-oriented approach for classification is way more accurate than the traditional classification method, OBIA. The OBIA used in this research is using SNIC segmentation and GLCM textural indices analysis. From overall accuracy, it shows that OBIA is 8% more accurate than pixel-based approach. The standard minimum for accuracy published by LAPAN stated that overall accuracy minimum is 75%. The pixel classification only gets 72% and it does not fulfill the standard, while OBIA gets 80% overall accuracy. The next conclusion are from the area calculation, the Surabaya City is dominated and covered by urban area with 134 and 130 kilometer. The smallest one is mangrove, which located in the edge of Surabaya City. And the last conclusion are based on classification, the green space area in Surabaya City only 63,720 kilometer cubic. It is only the 19% of the total area Surabaya City, which means the Surabaya City needs around 37,235 kilometer cubic more to fulfill this 30% of the green space area. Okay, this is the end of our presentation. Thank you very much for your attention.